Cool. Hi, I'm Edward from Media Suite, and this evening we're going to be coding a roguelike. We're live coding it. So I strongly encourage any audience participation. If you have questions, shout out. If you help me with typos, or you see a bug or a mistake, I always appreciate people bringing those up. And just in general, when I manage to do something awesome, appreciate any cheering or encouragement. It's always great to have some audience interaction. And yeah, and if I do something wrong, I mean, you can just cheer for that too if you like. So, who here has played a roguelike before? Cool. We've got
no idea.
one person. That's awesome. Okay, so yeah, well, there you go. That's a good example of one. So yeah, it is a little bit scary. So roguelikes are kind of adventure games from the days of yore, from the 80s, when we only had text-based terminals, and you would have your character who is an @ symbol, and he'd kind of explore through a world of hash symbols and dots and T's for treasures and G for goblins. And yeah, so I'm going to make one of those this evening. The reason I really like making roguelikes in JavaScript is it's a really good sweet spot between effort and the number of features you get in. So almost for every kind of couple of lines of code, you get a really cool feature. So they're really, really fun to program. It also highlights one of the reasons I really, really like JavaScript, is that it's really fast to get something on screen and something that you can share with other people. And lastly, it's also really fun to kind of engage with the community, and JavaScript's got an awesome community. Sweet. So, let's get started. So the first thing I'm actually going to do, we're going to start this where all good stories start. We're going to start it from the end. I'm going to open up an example of roguelike for you, so you know exactly what we're trying to build. And yeah, pull one out. There's one here in Alt. Cool. So this is the prototype. This is the one that I built for Camp.js. And so you can see here on screen, we have an @ character, which is the player. We have these hashes, which are walls. We have the dots that are floor, and we have the T that's the treasure. When we click the arrow keys, when we click the arrow keys, the character moves around, and if we get to the treasure, then we win the game. So that is a very similar roguelike to the one we're going to build this evening. Cool. So I will get started. So the first things first, we're going to create our roguelike.html. And then from there, we're going to create a pre-tag. The reason we use a pre-tag is because we want monospaced fonts, and a pre-tag, because it's for formatted code normally, automatically comes with monospaced fonts. So all the characters will be the same width, so our map is square. The next thing we're going to do is we're going to open up a script tag and get started on building a map. So a really nice way of building a map in JavaScript is to have an array of characters, so an array of strings, and each one of those strings are the characters that are in our map. So I'll just create a really basic map here. Cool. And then we'll create. So here we go. And we'll copy that a couple of times. Last but not least, we'll fill in this one with some more images, and I'll put in some walls, make it more exciting. And we'll put our treasure over here. Cool, so we have a map. So the first thing we're going to want to do is we're going to want to try rendering that map on screen. G'day, come on in.
Hi.
Make yourselves at home.
Are you joining us?
I have to take glasses.
Yeah, 2 pints down.
No problem. Sweet. So we're going to take this map around. You've got the right idea.
Or roguelikes anyway.
Yeah, roguelike.
Spot on. Cool. We're going to take this maze and we're going to make it a map. So one thing in JavaScript is a little bit difficult to deal with the array of strings later on. So just to save us some time, we're going to take each one of the lines and we're going to split the lines. Dot split. I'm going to split the lines, leaving nothing in between them. That's going to give us an array of arrays of characters rather than an array of strings. Cool. So we can get to the first document.getElementById, get to our first feature on roguelike, which is getting the map to render. So we'll set the inner HTML to map.join. We're going to join each one of the lines, and inside each one of those lines, so those are arrays of characters. Characters. We're going to join each one of those together with nothing, and then each line together with a new line. Map.map. Cool. Yep, cool, that's good to me. And so we can go and look at our browser now. If we go look at our browser at rl.html, we get our first error of the evening. Here we go. Putting it the wrong file. Sweet. HTML. Ed. Oh, hell. There we go. And our map renders. So that is the first step in building our roguelike. So we have our very own map here, rendering in the browser. We can edit it, we can add things, we can make it a maze, we can have 3 treasures if we want, and everything that we add will show up in the browser. So that's just that. That is our first 16 lines of code. So hopefully you're starting to see that we get a big payoff for just a couple of lines of code. So the next thing we want to do is, having a static map is wonderful, but it'd be really nice if we could move the player around. So we're going to create a player. For the time being, we're going to hard code in his position. We can see that he's in the top left corner, so he's at x of 1, y of 1, and he is an @ character, which is something that we'll use a little bit later, but it's good to put in place now. The other piece of information we're going to need is we're going to need a map from keycodes to directions. In a moment, we're going to do some keyboard handling, and we need to be able to map the keys left, up, right, and down, which are 37 through 40, to direction offsets. In this case, the top left corner is 0, 0. So moving -1 on the x-axis takes us 1 square to the left. So we're just going to go through these. So it's left, up, right, and down. And this is going to turn to 0 for up. And
I'll just keep the remote.
oh yeah, that's a good idea. You can just, if you just want to, you can just scoot the projector along a little bit, and that might make it a little bit easier to read.
That's good.
Sweet. Okay, and then down. So down is +1 on the y-axis, and 0 on the x-axis. Cool. Okay, so we'll get to our next next bit of code. So we're going to bind the onKey down event. That's whenever the user presses a key on the keyboard. We're going to capture that key, and if that key is one of key codes that we're trying to capture, const direction, because that's what we're going to get out of it, then we will move the character. If it's not one of the key codes we're trying to capture, I'm pretty sure it's key code, then we won't do anything. Yeah, we'll find out. JavaScript's a bit funny, but I think you might be right. Direction. Sweet. And then we'll open up a new. Cool. And we're just going to console.log direction. And one thing that's good to put in here as well is e.prevent default. The reason we want to prevent default is that when we're on a screen in the browser and we hit up, left, right, and down, it'll think we're trying to scroll the screen up, left, right, and down. If we prevent default, then it won't do the default action it does when you press arrow keys. So in this case, it'll stop us from scrolling.
Is it arrow keys? Top left.
Top left, yeah, top left is 0, 0. So if we hit left here, we get -1, up, right, and down. You can see them all showing up on the console, so that's working. That is exactly what we wanted to see. Sweet. And you can also see that if we make the screen too small, and I hit down, or up, right, whoops, down, up, right, and left, it doesn't scroll the screen. So that's what we got out of e.prevent default. Any questions? Sweet. Okay, so we're going to replace console.log with a move, because that's what we want to do, right? We want to move the player. We're going to pass the player in to the move function, and yeah, we'll get started on running the move function. So it takes an entity and a direction. I'm making this generic here on purpose. The way that I'm programming this is I try to keep the data and the objects as simple as possible, and then keep the functions as generic as possible, so that we can use on multiple objects, and you'll see why later. So we need a utility function, which I'm going to add in now, and that is add point. So in this code, I'm using points, which are just simple objects that have an x and a y property. Anything that has an x and a y property is technically a point. So a player, a box, and anything can be passed into a function that adds points, and it will successfully add those points and return a number that is like a point that is those 2 points added. There we go. So we're going to do new point, which is x, where point 1.x plus point 2.x, and a y, where y is point 1.y plus point 2.y. Cool. Now we have that. What we're going to do is we're going to add the current position of the entity, which in this case is the player. Position. Add point. Entity and direction, and that's going to tell us where the player is going to try to move. So we take these directions that we had earlier, and we add those to the player's current position. So we try and move them left or up or right or down by 1 square. And then we want to know what character is he going to encounter. Character is he going to encounter that square? So we access the map, and we get new position dot y and new position dot x. It may look a bit odd to index by y than x first, but we have to index by y than x first because we have an array of arrays, and so that that results in the first query getting us the y position, the second query getting us where we are along the x axis. Sweet. And then based off what we find there, we want to do different things. So if we find that at that position there is a floor tile, then we're pretty keen to have the player teleport to that position. So we're going to pass an entity and a new position for the entity. Cool. So we'll just go have a test of that. Okay. We'll quickly write a stub for the teleport entity method. Takes an entity and a new position. We'll just have a console.log new position. Sweet. We'll jump back over to from. Cool. New position is not defined. Cool. I've spelled position wrong. Cool. And if we go look at our console, cool. So you can see here, I'll just clear the console. If I hit left, nothing comes up, we can't move into a wall. If I hit up, nothing comes up, we can't move into a wall. If I hit right, we get the new place we're going to move to, and I hit down, we get the new place we're going to move to. So that's working correctly. So now that we can teleport an entity, we need to modify the map to show that the entity is moved. So the first thing we're going to do is we're going to set entity dot y and entity dot x. So the position that the entity is currently at, we're going to blank that. We're going to set that to be a floor tile. And then the position the entity is about to go to, which is this new position, And to make this a bit nicer, I'll destructure this so we can take the x and the y values and use them directly.
So what's it when you use instead of full stop in a footer or something like that?
Sorry, say again?
Floor tile.
A floor tile?
Floor tile.
Yeah, dot is a floor tile.
I thought you were meaning something like octothorpe.
No, there's no fancy name for a full stop as far as I know. And then we're going to take the entity's character because we used that character and put it on the player earlier, so we're going to replace it with his @ symbol. Last but not least, we're going to return a new entity, which is going to have x, y, and the character set entity dot character. So the idea here is that we are keeping these functions pure. We just pass them what they need. They do call out to map, but there's a good reason for that, just for getting things done quickly. And we can set the player to equal the return of the move here. Cool. So if we go have a look at the code, refresh, quick make sure I've saved that. X, Y, char, entity, char, table entity. Yeah, we're going to return the entity in the case that he doesn't move. And then the player will equal direction. So what's up? Is it?
Re-render the
Yeah. Okay. I'm pressing arrow keys and we're not moving, so that makes things more exciting. Let's have a quick look at what we've implemented and check if there aren't any issues. So we're getting the new position correctly. Entity.char. Yep. Passing an entity, we're passing in a new position. We know that it was working correctly up to this point. We set the map .y, map into .x. Returning a new player object. Ah, I know exactly what's going on here. So earlier on, we introduced this here to render our map. And then what we need to do now that we need to render more than once, now that we have things that can move, we need to introduce a render function. Cool. And so while the player was moving around the map, having a jolly old time, we didn't see it because the player
was updating, but the
yeah.
view wasn't.
Yeah, exactly. The player was updating, but we weren't re-rendering each time the player presses a key. So we need to render once as our initial render, and then we need to render each additional time that someone presses a key. So now we have a player that moves. Sweet. And now, if we go back, we can get our win conditional sorted out. So if we add another condition where the character the player is about to step onto, if that character is the treasure character, then we can do an alert, and we can say, congrats, you win. Sweet, save that, go back to the code, refresh it, and hit one of our 3 treasures. We decide to make lots, and there we go, we have an alert. So that is my basic roguelike. That's the one that I made for Camp.js in my other presentation. And now, because we have a little bit more time, we're going to push it a lot further. So I'm going to add a couple more features. The features this evening, I was going to add basic, really basic line of sight. We're just going to render the squares around the player and add another character. So we're going to have a robot that moves around with the player. So we'll get started on those. So first things first, the way that we're going to do line of sight is we're going to go back up to our render method and we're going to filter the tiles that show. So first things first, we're going to make a filter map method. Filter map method is going to take a map and a player. The reason it takes the player is because we use the player's position to work out what they should and shouldn't see. So we're going to go through for the map, .map, for each line of the map and the Y position, and then for each line we're going to map that again, so for each character and the X position. So this is equivalent to nested for loops. We're going to check if the player if we can see point X, Y, and the player can see it. Cool. And then if they can see it, we're going to return the character. So we return it exactly as it is, and if they can't see it, we return an empty string. Cool. So now we filter map, go down and we'll implement can see. So can see takes player in this case, and it takes an X and a Y position, which is the tile we're checking to see if the player can see or not. So in this one, we're going to return pretty simple. With it, to cheat a little bit here, we have a utils.js because I didn't want to write code to work out a rectangle around the player. So I've implemented this method here, which is rect around player. You give it a point and a diameter, and then from that it gives you the coordinates of every single point around that one. So if we have the player, you get the player's square and then the squares around him. So you get all those 9 squares in a block handed out to you. These tools are pretty standard in most game libraries. Things like rects and vectors are all pretty well handled. Cool. So we're going to get a rect around the player. We're going to get the player. Oh, we need to get the. Yep, that makes sense. We're going to get the player and we're going to give it a diameter of 3. So it'll be 1 square either side of the player in all directions.
This depends on the brightness of the torch or something, is it?
Yeah, basically. That's the idea, right? You can get more if you small. You can get more visibility if you have a brighter torch, for example.
And purchases.
Yeah.
In-game purchases.
Yeah.
In-game purchases might be out of scope for this evening, but that would be very entertaining. Cool. So we are going to check if the square that the point that you have passed in is inside the list of points inside the rectangle around the player. So we're going to take a point. This is the point that it turns, and we're going to say if point.x is equal to x, and point.y is equal to y.
So you can run this how often?
As often as you click the arrow keys.
And it's going to run for the immediate adjacent
Yep.
squares.
Yeah.
So it's going to end up calling rect around player a bunch of times.
Sure is, but on the upside, that's really cheap.
Okay.
Rect around player basically calls a nested. It calls range twice, and then blobs them together.
Okay.
So
I've just been wrangling cation for the last couple of weeks, so my mind is.
yeah, no, I know the feeling. So you make your point. With this one, it'd be very easy to memorize.
I was going to say, yeah, you could.
Really, really easy to memorize.
You
But
could just call that rect first, and then.
yeah, absolutely. I just don't tend to optimize things before I have to, because there's no reason to calculate this rect more than once given a single player position, and it's quite easy to store a dictionary of player position to available squares, which is a good optimization as long as stuff doesn't get destroyed around you in between, which it probably isn't. Yeah. On the upside, this is only done when we render, so there's not any particular issue here. So yes, it is inefficient, but I also find it quite easy to read. Yeah, sweet. So we can see we go from top down, we filter our map, we go through every line and every character, and we check that from the player's position, can we see that position on the map. If we can, we display it, otherwise we replace it with a space. And to do that, we check if it's within the rectangle it's around the player. Cool. And last but not least, we need to actually use our method. So I'll go filter, map, takes a map and a player. We'll go have a look. That was a lot of code without testing, so I'd be pretty surprised if it worked out of the box. Very impressed. Cool, I see what's wrong there. We're missing one set of parents. There we go. Then we go into our console. Rect around player. We have to go and import the utils. We just need to do a source equals ./utils.js /script. Cool. And that way we now have a basic line of sight. So as I'm walking around as a player, I can only see a couple of squares either side of me, and that makes exploring around in the dark quite a bit more exciting. There we go. So that's basic line of sight. This afternoon I did implement proper line of sight from scratch, and after spending I think it took me about 30 minutes to implement Bresenden's line drawing algorithm, and then That's a lot more work. So I strongly suggest if you'd like to do that, you incorporate a library. I've got a library that I'll link to at the end of this called Roguelike.js, which is really, really excellent. It implements all that type of functionality for you. So you can just use that out of the box. Yeah, I
What's
can.
it called?
Rot.js. It just includes things like map generation, AI, scheduling, all that good stuff. So you don't have to write that yourself. And I encourage you to focus on the parts you find fun. If those are the algorithms, do the algorithms. But if they're not, if you just want to make an awesome game, just call out to Rot.js and don't worry about it. Cool. So we have line of sight. Now we have line of sight. It's about time we added an AI player. This is our second fancy feature. So because of the way that we've written the rest of the code, we've used a number of pure functions. We haven't really used objects. We don't tend to call methods on objects. We just pass pure data to objects. It's very easy to add an additional player. So we're going to add this robot. We're going to put him somewhere down here. I quite like putting him here. That sounds good. Going to work out his position. So that's 1, 2, 3, 4, 5, 6. And he's... So it's going to be a y of 5. And he's 1, 2, 3, 4, 5, 6, 7, 8. So that's a y of 7, an x of 7. Cool. And now we know what a robot is, and a robot has a character of R. And that's one of the reasons why we've given our objects characters, so we know how to render them. We're going to make a really, really simple change, and we'll see if everything lines up well. So if we go back down to where we press our keys and we move our players, each time the player moves, our robot is now also going to move. And we're going to move him by passing him into the move method. And because we use pure data and reasonably pure functions, we should be able to trace through this and see that when we pass in the entity, all of the same stuff happens. The robot still needs to check the new position, check the new character, and then if he can move there, he does. But one interesting behavior we have now is that if the robot hits the T, he will win. And it'll still say that we won, but that's not too bad for now. So one thing I will do is I will set the diameter of our line of sight to really, really large, so we can see the entire map. And one thing I really encourage here is fiddling around with these parameters. There are a lot of fun things once you have this little base that you can tweak just to see the game behave completely differently. You know, everything from snake trails to just this is the entire map rendering. So you can see now our robot moves around with us. And if I go all the way over here, I can actually walk the robot into the treasure and he'll win. So that's really fun. That was something I did accidentally this afternoon. I thought that's really cool. I thought, you know what would be even better? If we actually go and have a look, we have the entity, we can check if the entity character is the robot's one. And now we can actually go, oh no, the robot wins. And we can have us win in the case that it's anything else that hits it. So now if I hit this, we get, oh no, the robot wins. And if I go down there myself, we get, congratulations, you win.
Nice.
Cool. So it's a really, really, really basic AI. You can make him move in random directions. In many other games, I've made him move in towards the player continuously, which is really fun. And you often design your levels so that he gets caught in interesting places. But yeah, in however long we've been recording for, we now have a game with basic line of sight. We have AI, we have a map, and I'm going to hand that over. You guys can extend that and play with it how you like. Strongly suggest there's all sorts of things to play with from here on out, and I will hand you across that library as well, so you can plug that in and get map generation. You can plug that in and get more advanced line of sight and shadows and raycast. There's all sorts of clever stuff. But there is a basic roguelike, and that is the end of my presentation. Cool. Sweet.